Hello. So today is going to be an intro to rectilinear motion using a couple examples from the ladybug and the branch. So our main problem, a ladybug moves along a branch so that its position from the trunk of the tree at time t is given by s of t equals t squared minus 6t plus 5 for 0 less than equal to t less than equal to 5. S of t is measured in yards and t is measured in minutes. So the first question is asking us to find an equation for the velocity of the ladybug. This is fairly simple because velocity is just the derivative of the position function. So we just take the derivative of s. So s prime of t is equal to the velocity is equal to 2t minus 6. So this is our velocity function, t. Okay, sketch the graph of v of t. So minus 6 would be somewhere like right here, 2t here. Oops, I'm pretty sure there's a ruler. Oh, never mind. So just roughly sketching something like that, maybe. Doesn't really matter, but what does a negative velocity tell you about that direction the ladybug is walking? So a negative velocity, in this context, negative velocity would always mean that that an object is going to the left or down. And since it's going across a tree trunk, it's going to the left. So it's going left, and if you think of it as like this is the tree and this is the tree branch, that would mean that the ladybug is going back towards the tree. So left towards the tree. Okay, so what does a positive velocity tell you about the direction the ladybug's walking? So again, if this is the tree trunk, this is the branch, and a positive velocity always means to the up or right. So in this case, we'd be going this way, so to the right. So right and away from the tree trunk. Away from tree trunk. So at what time, and the next question, at what time is the ladybug at rest, and how do you know? So at rest means what time is the velocity of the ladybug equal to 0. So we just need to find when the velocity of the ladybug is equal to 0 using our velocity equation. So set 2t minus 6 equal to 0. So you'll get t is equal to 3. So at 3 seconds, let's erase these drawings. So at 3 seconds, the ladybug is at rest. Let's look at what is happening with the ladybug at t equals 1. Find v of 1. Use proper units. Oh, this is 6. So v of 1 would just be found by putting 1 as t in our velocity equation. So v of 1 would be 2 minus 6 equals negative 4. And the units in this case would be yards, since the position is measured by yards, per minute. So negative 4 yards, let's abbreviate, yards per minute. Find v prime of 1. What does your answer mean in the context of this problem? Use proper units. So this is a problem where we need to find the derivative of the velocity, and the derivative of our velocity equation is just 2. So v prime of t is just equal to 2. So that means v prime of 1 would be 2. And the units, since we are measuring now, we're measuring yards per minute. So it would be 2 yards over minute squared. And this makes sense because what is the derivative of the velocity function? Acceleration. And acceleration is always given by a square in the denominator, because in this case, we're taking a yards per minute as our rise. So if you're thinking about it as a change in y over change in x, and this is about the velocity function, if the units on top is yards per minute, and the units on bottom, the x would still be minute, you have yards per minute squared. So the v prime of 1 is equal to 2 yards per minute squared. And what does our answer mean in this context? It's just that the velocity is increasing. So velocity, let's erase this. Okay, so velocity is increasing, because, and this is where you need to get specific, because you get 1 point for the correct answer and 1 point for the y. So you really need to go in depth and make sure that your y is correct. So because v prime of t is greater than 0 at x equals 1. Velocity is increasing, and because the acceleration is positive. So I think we can just erase all of this. It's looking a bit messy. Okay. Can you zoom back? Okay, it's fine. And then we need to, at t equals 1, is the ladybug speeding up or slowing down? And how do we know? Let's just write the equation for the velocity function here. 2t equals 6. Then v prime of t is just equal to 2. It's equal to a of t, which is acceleration. So at t equals 1, is the ladybug speeding up or slowing down? And how do we know? So we just found, actually, what v prime of 1 is, and that was -4. Wait, no. V prime of 1 is 2, sorry. V prime of 1 is 2, and v of 1 is -4. Is the ladybug speeding up or slowing down? Is asking us to compare the signs of velocity and acceleration at t equals 1. For example, here we have the velocity as a negative value and acceleration as a positive value. So since these signs are opposite of each other, that means that the ladybug is it's slowing down. I think you would write something like, since velocity is negative, I'm just abbreviating, is neg, and acceleration is positive, the velocity is going to 0, velocity is going to 0, and the ladybug is slowing down. I'm not going to write that, but that's the main answer of this question. It's important to think about it as the velocity is going to 0. That's why it's slowing down, because it starts off at a negative value. If you think of it as a number line, negative value here, and our change in velocity, or our acceleration, is positive. So if this is 0, this is -4, and our change in velocity is positive, that means that the velocity is going here. It's going towards 0, meaning that the overall ladybug is slowing down, since the velocity is also slowing down. It's going to 0. And a challenge question. Okay, let's erase this. Challenge question. Off another branch of the tree, a worm is crawling at a velocity given by v of t is equal to -4t plus 3, where v of t is measured in yards per minute and t is in minutes. Find a possible function that would give the position s of t of the worm. So, we solved a question similar to this in question 1. We need to find the equation for the velocity given the position function. But now we need to create the position function given our velocity function. or velocity equation. So that means, oh, where'd it go? Here. That means that we need to just create, it doesn't need to be right. There's multiple correct answers, but create a function so that its derivative would be equal to this, negative 4t plus 3. When you think about it like this, there are many possible equations, but let's just think of one. So s of t is equal to negative 2t squared, then plus 3. So plus 3t. If you think about it in an overall sense, this makes a good position function, because when we find the derivative of this, when we find the velocity function, we would have, let's take the derivative, negative 4t plus 3, which is the same as here. So this is a good position function. Find a possible function that would give the position. So yeah, this is our answer. And second challenge, at t equals 1, is the worm speeding up or slowing down? Oh yeah, this is the worm. So t equals 1. So our velocity function, let's just rewrite it, is equal to negative 4t plus 3. And our acceleration function would be the derivative, so just negative 4. T equals 1, is the worm speeding up or slowing down? Well, it's v of 1 would be negative 4 plus 3, so negative 1. A of 1 would be negative 4. So you can see here that the signs of the velocity and acceleration are both the same. So they're both the same. And if they're both the same, that means that the object is speeding up. We would say speeding up, so speed, let's write our answer up here or something. Speeding up because BC. Velocity, let's just abbreviate a lot of stuff. So V is negative and A is negative. So velocity is going towards 0. So velocity is, not going towards 0, is going away from 0, so going away from 0. And that's why it's speeding up. That is all for this. Activity, for this worksheet. And just a quick tip, it's really helpful in your explanations of why something is speeding up and slowing down. Say that the velocity is either positive or negative, and the acceleration is either positive or negative. And then think about it on like the number line. If the velocity is going towards 0, an object is slowing down. If it's going away from 0, it's speeding up. So that's a helpful tip on how to write like the why part of your answer to these types of questions. Thank you.